everyone, welcome to the course Design Practice lecture module 31 and 32. I am Sanjay Kumar, course TA, and again I will continue this week also and I will in this week I will cover design of work system. Okay, this is a new topic, and in this topic you will learn how to design your job and your workshop or your method process, and how you can continue quantitatively measure the time which is required to process any product which in a workshop. Okay. In this module I will cover first one, that will be our what are the work system, what are the elements of work system, and after that I will cover what are the all elements in detail. Then after we will do some problem solving. Okay. So, what is the work system? Work system is a physical entity, that is a system that consists of human, information, equipment designed to perform useful work, and it contributes to the production of a product or delivery of a service. Okay. Suppose that if you want to develop a one system for your organization, so how you will have to develop a system for that. Okay. So, it includes everything: manpower, machine, money, and you will have to integrate all the things in a such a way that there should be some suitable system that is required to develop a successful organization. Okay. Here for example, here what you are saying, worker operating a machine tool in a factory. Okay. So, in factory, in actual case, in each machine M1, M2, M3, in every machine there are certain 2 to 4 or maybe one worker is assigned. Okay. So, for worker case, you will have to satisfy their need. Okay. Robotic welding line in automatic plant, parcel service agent driving in a delivery truck to make customer delivery, designer working at a CAD workstation. Okay. So, you can see here these all elements, when you will integrate all elements, then there will be a formation of work system. Here elements of a work system. Here you can see human workers are involved, equipments are required, and certain information are required, so that when you will integrate all the things, then it will get processed out and it will convert in a useful work. Okay. Work can be either in a form of product or service. Okay. I will discuss work system in detail now. Okay. As a field of professional practice, work system includes three things. That is, first one is job design, second one is work measurement, and third one is work management. Okay. Job design. Job design is related to workers. Okay. This is the analysis and design of tasks and jobs involving human work activity. Third one is work measurement. When worker perform some work, then how you will quantify their effort. Okay. So, you will have to use certain methods so that you can quantify their effort. That is the analysis of a task to determine the time that should be allowed to perform the task. And third one is a work management. Okay. This is the actually more basically related to management. Okay. It is an administrative function that must be accomplished to achieve high productivity and effective supervision of workers. Okay. So, first I will discuss job design. What is job design? Job design specifies work activity of an individual or group. It involves specifying the content and method of job. Here certain questions must be asked before designing a job. So, what will be done? What are you going to produce in your factory? What will we do the job? Who will do the job? And means it related to workers type. It may be either from technical background, non-technical, either you can divide in a skilled or skilled and non-skilled labor. Okay. How the job will be done, and it means it related to your process. Suppose that you are going to make a nut, fabrication of nut and bolt, then which machine should be used? That is the question. Okay. Then other question is where the job will be done, that is related to place, and this is very important in a work system. Okay, because if you want to produce something that is not acceptable in that region. For example, so if you want to open a chemical plant, okay, so you can't open this plant near to Agra, because environmental and pollution board will not allow you to establish a company related to chemical. Okay, that may harm to Taj Mahal. Okay, this is the one aspect. Another aspect, lot of aspects, technical aspect is also there to in a selection of process and place. And last step is ergonomics. Okay, this is related to the comfort level of human being. Okay, and I will discuss everything in detail in next slides. Okay, job design success. If you are designing a job properly, that resulted in it, for that you must be carried out by experienced personnel with the necessary training and background consistent with the goals of the organization, because experienced person is very important, because in last slide you seen that there are a lot of factors are involved in a job design. So, experienced person matters. And second thing, consistent with goal of the organization, means whatever you are designing for a work system, always keep in mind that what is the goal of your organization. Without goal of your organization, if you are deviating from that and you are designing a proper work system, so it will not work in actual condition, because goal is in top priority, it must keep in top priority. Now, specialization is business advantages. What are the advantages of job design for management and for labor? Each has a, for management, simplifies training and higher productivity, low wage cost. Okay. Simplifies training, it means it saves money and time, because in a structured manner if you are executing your plan, then lot of time can be saved. Okay. Higher productivity, proper job design results in higher productivity. What is the productivity? Productivity is the what is the output of your organization in a certain input. Okay. And productivity may be in form of time, money, worker efficiency, etc. Okay. So, proper job design resulted in higher productivity and low wage cost. Okay. This is also important benefit related to cost. Okay. Because in a work system you will also perform cost analysis. And for labor, low education and skill requirement, means if you have planned proper job design for your organization, then you know how many worker is required for skilled one and unskilled one. Okay. So, you can estimate the number of skilled and non-professional labor is required for organization. Minimum responsibility. So, each worker has described its responsibility, and he or she is responsible only for their task, assigned task. Okay. Third one is minimum mental fatigue. If you have designed a proper job design in a work system, then what will be happen? Each worker will be allotted balanced workload and job satisfaction. So, these are the benefits in a business of job design. Now, job design has a certain disadvantages also. Okay. Here for management you can see difficult to motivate quality. Okay. Sometimes you can't improve your quality of product in a short notice, because you have already planned and you have already proper plan for your work system. So, you will have to change everything if you want to motivate the quality of your product. Workers dissatisfaction possibly resulting in absenteeism, high turnover, disruptive tactics and poor attention to quality. It means in a competitive world what happens, sometimes quality is sacrificed to compete with another industry at higher pace. So, this may result in a poor, that in a technical term that may result in a poor work system design, and the company may be lost in near future. Okay, for labor, monotonous work, limited opportunity for advancement and little control over work, little opportunity for self fulfillment. Well, these are the some limitations of job design. Now, at the behavior approaches to job design, what are the approaches? First one is job enlargement, second one is job rotation and third one is job enrichment. Job enlargement, here giving a worker a larger portion of the total task by horizontal loading. Horizontal loading means, suppose that is the level of difficulty. Level 1, level 2, and if you are assigning more work, suppose that a labor is working and he is capable of producing something, suppose that x amount of product, okay, and if you are assigning him y, now y amount of product, so at same level and y is greater than x, then it means he is getting more workload and difficulty level is same, there is no change in difficulty level, that is called horizontal loading, and it you can say job enlargement. Okay. Now, second one is job rotation, workers periodically exchange jobs, and example, you in any educational institution or industries, the assignment of guard is rotated periodically. One day he will be assigned in a main gate, he will another day, it may be possible that in another day he will assign in a hostel. So, this is the job rotation and it helps to motivation, better motivation of worker. Okay. Third one is job enrichment. Here, as name suggests, increasing responsibility for planning and coordination tasks by vertical loading. It means same, I am taking same example here, that is the level of difficulty, and here is L1, L2, L3. Here, suppose that a worker is working at this level of difficulty and he is producing x amount of work. Okay. So, now if you are assigning him some different work which has a difficulty level of L2 and L2 is greater than L1 and amount may be same or lesser than x, then that is called vertical loading of a worker. Okay. Here what you are doing, you are making him a more responsible to the organization. So, he may feel motivated and he may feel motivated for doing new work. So, here you can see that you are not changing, you are not replacing the worker, your worker is same, but you are only tweaking. Here what you are doing, you are assigning him more work. So, here you are rotating his job periodically, and here you are making him more responsible. So, that is the approaches for a successful job design. Now, design of work system. These are the tool of designing of work system that I have already explained. We have approaches to job design. Second thing, team is required for a designing of a work system, and some technical tool that is called method analysis. I will explain in later. Motion study, working condition. Okay, these method analysis. So, this is more related to process, and this is related to time analysis, and here this is more related to environment. Okay. So, for designing of work system, these things are required. Okay. Team member, some technical analysis, that is method analysis, motion study, working condition. Okay. Now, first I will explain method analysis for the job design. So, there are several steps which I have to follow for analysis of a method analysis. Steps. First step is job and task or process selection. It involves following considerations: economic consideration, technological considerations, human considerations. First I will explain economic consideration. Okay. Economic consideration, here cost effectiveness, to check whether or not the work study application would pay. First you will have to check what you are planning, and it should not be go in a trash, it should be implemented in a industry. So, first you will have to check whether whatever you are going to design for a work system, so that should be cost effective. For this, key profit giving costest operation with largest waste scrap should be attacked first. Okay. Here you will have to do cost analysis of each process at every step, then only you can make a system more cost effective. Next, after analysis, next bottleneck operations, repetitive operation, repeated material handling operation should be studied, and if required, if necessary, then it should be repetitive operation should be minimized or removed. For locating most important operation, that Pareto analysis could be used. This is the again this is a technical tool for analysis, and I will explain later. Yeah. Second one is technological consideration. After realizing that your work system design is going to be very cost effective, then you will have to check, you have to go in a technical aspect, you will have to check. The analysis involves application of work study for the selection of the operation process where new technology, for example automation, should be introduced. Okay. Here continuously progress to improve productivity of a system, automation is required, and automation actually it means main drawback of automation is minimization of worker, and this is also a benefit to adopt a automation. And what another benefit of automation is, it will improve accuracy, production rate, etc. Then you will have to take consideration in human being. That analysis involves location of those operations which present the sources of dissatisfaction and annoyance to the worker due to fatigue or monotony or unsafe environment or a work which is clumsy in nature. That is why we studied in earlier slides, that is that called job enlargement, job enrichment, and job rotation. Okay. This is a one kind of methods which may help in reducing absenteeism of worker, improved self motivation, and job satisfaction. Okay. So, this is the first steps. Now, second step of a method analysis, that is the recording the fact. So, whatever you are visualizing in your industry or analyzing in a industry, you will have to make a documentation of that. So, for that you will have to record those things. So, there are various tools are involved in a recording for fast recording purpose. First is chart. Chart is a basic tool which may help you in a quantification or separation of work in a system. And charts are based on sequence, that is the outline process chart, flow process chart, two-handed chart. These are the variety of charts are available for in a method analysis in a work system. And second one is based on time scale. So, you can make you can take consideration of time in a process. So, that is first method is multiple activity chart, second one is SIMO chart, and another method is diagram. So, diagram is a very convenient and fast way to record the fact. It may be of the following types: flow diagram, string diagram, travel chart, cycle graph, and chronocycle graph. So, these are the very important tools for in a method analysis. Okay, and I will explain each one of them in next slides. So, first type of chart is operation process chart. Okay. What is the operation process chart? This is a graphic presentation of the sequence of all operations and inspections involved in the process. Okay. It means it is a graphical representation. So, graphical representation mean any worker, skilled or unskilled, can understand. So, this is very popular method. In this chart, all components or material entry points are indicated by the horizontal lines, and the processing of these materials are shown vertically. Okay. Here all operation and operation process chart provide a compact overall view of the whole system of operation involved in the manufacturing of a product. Okay. So, these are the benefits of the operation process chart. Here to make a graphical representation of your system, you will have to use some symbols. So, these are the 5 basic symbols which is used in a process chart. Okay. And it is recommended by ACME, and there are 5 standard symbols. First one is operation, and this is represented as circular. Okay. Solid circular, if you see. So, this one. This is the main step of the task, job involving modification change. So, if in a chart you are seeing this one, so you may consider that there is a operation is going on. Second one is inspection, that is the checking quality and quantity, and this symbol is used for there is a quality department. Okay, there is where sample is going to be inspect. Okay, so this symbol is used in a for inspection purpose, and there is a arrow you can see, that is for transportation, for movement of person or material. Fourth one is delay. If suppose that you in an assembly work system, here is a one workstation A1, A2, A3 and A4. So, suppose that it takes 5 minutes to produce one part, and it takes 7 minutes to process next step. So, here you can see that produced part from A1 workstation, it will move through, transported through some automated guided wheel, and it will reach at A2 point, but he has to wait till this save up to the for extra 2 minutes, so that this part should be completed in a A2. So, that 2 minute is a, you can see, represent it as a delay temporarily for waiting time of operator or material. And fifth one is storage. After inspection everything, this is the storage department from where your product is going to market. Okay. So, that is why it is sometimes it says permanent delay. Okay. And this delay results in lot of money wastage of money and place. Okay. And suppose that if there is in any workstation where two operation is happening parallelly, then you will have to make this kind of symbol. For example, suppose that in a workstation where operation and inspection is happening parallelly, then you will represent it as a one square, and in center there is a circle. Okay. For square, that is the inspection, and for circle this is used for operation. Okay. So, this symbol is used for parallel operation. Next, here there are variety of process chart. First type is outline process chart. It gives the overall view of the whole process by recording in sequence only the main operation and inspection. Okay. In this chart only operation and inspection is measured, means operation you will represent it as a circle, and for inspection you will represent it as a square. So, it uses only operation and inspection symbol. Here in a two-handed process chart, it provides a synchronized and graphical representation of the sequence of manual activity of the worker. Two-handed, as name suggests, here whatever you are doing, suppose that you are assembling a nut and bolt. So, you will have to, your both hand will be involved in assembly of nut and bolt. So, whatever you are doing from your left hand, it should be recorded, and whatever you are doing with your right hand, it should be recorded parallelly. So, that is the that is why it is called two-handed process chart. Records the activity of the left hand and the right hand of the worker as related to each other, and a time scale can also be provided on the chart. So, benefit of this chart is that you are parallelly you are making counting working time of both hand, and that is the time study you are also doing here. Okay. And this is used for repetitive work for short duration. And third one is flow process chart. Here records all the events in a sequence using process chart symbol and marks distance and time taken for completing an activity. So, this is more beneficial from both chart as compared to above two chart, because it give you distance and time measurement. Okay. So, I will explain each chart with some examples. So, first I will explain outline process chart. What is outline process chart? It is the first step to a detailed analysis of a process, and it gives the overall view of the whole process by recording only the main operations and sequence in a proper sequence. It uses only operations and inspection symbol, as I told you in earlier slide, operation and inspection symbol. So, this symbol is for operation and this is for inspection. Here I am explaining using one example. Here this is a outline process chart, it is made in some industry. Okay. So, here you can see there each word has some significance, part number. So, this is the for recognition purpose, which for which part you are doing this chart is for. Part name is repeated plate assembly, location where it has been done, assembly shop, method which method is used, charted by who is the working personnel who has made this one and who has approved it. Okay. So, we will focus in this part only. So, here you can see there are two rivet of this size and they are plate 1 and plate 2. So, here you can see what you will do, you will have to riveted both plate, so that there will be a rivet joint between two plate. Okay. Both plate will be joined by rivet using your rivets. Okay. So, what you will do for plate 2, first you will have to cut with a specified length. It means cutting means it is operation. So, that is why there is a circle. Okay. Again you will have to make a drill of certain diameter, so that rivet joint can be inserted. So, again it is operation. So, it is represented as circle by circle. Then unspent for burr. So, whatever you after drilling the plate, you will have to inspect whether there is a notch or burr is there or not. So, that is for inspection purpose. So, it is square. Again here plate 1, again you have to perform some operation. You will have to make a cut of certain size of that plate, with again drill, then counter sunk for you will have to check inspection purpose, unspent for burr, then locate plate. After doing both, you are making closure, to both plate, and then locate plates one on top of two, then insert rivets and form rivet heads and unspent. It means again here all steps you can see that either they have used operation or inspection, operation, inspection, operation, and here is inspection, final assembly, inspection of final assembly. So, this kind of chart is known as outline process chart. Here you can see the only operation and inspection is used. Now, second one is two-handed process chart. Here again I am going to make a take example and explaining how two-handed process chart is going to make. Here I am taking example to assemble two washer and nut to bolt. Okay. Again wherever you will get this kind of chart, then there should be some coding should be is there, that for part number, for recognition purpose, operator who has made it, again chart starts, okay, chart ends, completed assembly, method, and charted by and approved by. Okay. In some chart date is also there. Okay. Here you can see you have to assemble two washer and nut to a bolt. So, you will have to use both hand to do this assembly. So, in a left hand what you are doing, move to bolt. Okay. First you are moving your hand to bolt, and that is for transportation symbol. Okay. Again here parallelly what you are doing, right hand with the right hand move to first washer. Okay. Again since you are moving your hand to the first washer, again it is a transportation. Then with in the left hand grasp the bolt. After reaching the bolt location, you will grasp the bolt, and that is the operation, because you are grasping the bolt. Again here parallelly you are doing with the right hand, pick up, grasp the washer, then you are picking up washer, so it is operation. Then in the left hand move to position. Again you have to make an alignment so that assembly should be done. So again it's a transportation. Again you are doing the same thing with the right hand. Then you are holding your volt, that is for storage, okay, permanent storage, and here assemble to volt. Then after that you will have to make stationary, and you will have to hold till the rest of the operation is done by your right hand. Move to second washer, pick up grasp the washer, then to position, then assemble to volt. After that move to nut, here transportation, pick up the nut, again operation, and after that move to box. So move and to position. So again now you are, after assembly you are moving your left hand so that it will be kept in a box, again to the position, aside to box, you are moving aside box, then assemble to volt. Okay, this is the, so here you can see that you will have to use both hands and process is recorded. Okay, so that's why involvement of two hands make it name two-handed process chart. Now third one, flow process chart. Now I will explain you what is the flow process chart. It uses all the 5 symbol, unlike the outline process chart. It uses all the 5 symbol and provides the total sum detail of the process and job under study. Here a flow process chart may be of the following types, that is called man type, material type, and another type is called machine type. Machine type, and there is another type, that is the hybrid type. You can say man and machine type, man and material type. Okay, so I will explain some of them. Here material type, for operation is gear manufacturing, part number is something like that, method charted by someone, approved by someone, and date is someone on some date. Okay, here you can see in this example, shop, machine, shop. Here these are the operation, transport, inspection, delay, storage, and distance is counted as 116 meter, and each has assigned some coding 58252. Okay, here since it is a material type chart, here you can see element description for gear manufacturing. So first you have to take a bar of diameters of 50 mm, so from store. So this is placed somewhere, so this is storage, sent to cutting machine. So you will have to transport it, so there is a symbol and here it will reach. Okay, so you will have to count distance, so parallel it is counted as 15 meter. Again cut to size, it means operation, this is related to operation. Okay, send to lathe, again transportation. Then from delay or wait, so there is some delay, suppose that there is some delay, so there will be this one. Again facing drilling and reaming. Okay, there again there will be some operation to lathe, again transportation, again facing on other side, turn to size, again it is a operation. So this is going on, and after finally what happens, after make heat treatment, weight, hardening, and inspection, then you will have to inspection for each one, every property, so that gear can be sold out. Okay, to spare part stores, that is for transportation, and storage for reuse. Okay, so either for reuse or for selling. So this is the material type flow process chart. Here you can see you have taken all the symbols to make a chart for gear manufacturing. Okay, here distance and time is parallelly counted. Okay, so this is the more elaborative, provides more detailed information as compared to outline process chart and two-handed chart. Okay. Now next is man machine chart. This is the hybrid chart. this explains graphically the activity of a man and machine he is attending with reference to a time scale. This study is undertaken, it means in this chart man and machine, involvement of man and machine is recorded. In this type a study is undertaken to find what number of machine each worker can operate or how many workers can work on each machine. That enables the management to minimize the idle time of the worker and to use the machines to their full capacity. Idle time. Okay. This is the time when idle time may be related to worker or machine, both. Sometimes machine is waiting for next operation and sometimes worker is waiting till the operation in a machine. Okay. First I will explain. I am taking 3 example for man machine chart. Here condition 1 is that one worker operates one machine. So, in this example you can see that this is the time in a y axis, this is the time. Okay. So, what he is doing first, this is the setup time. Okay. This is the operator and this is the machine. So, what he is doing, he is setting up machine so that machining can be start, and this is the time required. Okay. And this time machine is being set up and he is, because only one machine and one worker is there, so he is doing this work. So, he is involved somewhere in this machine. So, that is for your, this time is setup time or working time for work operator, but you for worker, and after that when machine will start processing and he has to wait till that part is fabricated, machined or fabricated. Okay. So, suppose that that machine is taking this much amount of time. Okay. So, till this time this operator will have to wait. So, this is the idle time of the operator. So, here in this case you can see that if you have assigned one operator to one machine, so he has to wait most of the time until that work is finished in that machine. Okay. So, here you can see idle time is significant. Okay. In second case you can see one worker operates two machine. Here there are two machine is available, M1 and M2, and worker only one worker is there. So, what we will doing, here you can see in a machine 2 is already running from the previous analysis. So, in meantime, in that time worker, what this worker is doing, he is preparing that machine, setting up that machine, so that machining can be start in a M1. In meanwhile, in that time M2 is already running. Okay. So, that is the, here you can see all M2 is already running, M1 is being setting up, and worker is involved in M1. Okay. After that, here M1 will start working. So, and here after that, here what he will do, now worker at that time that M2 will finish his machining process. So, he will have to again remove that part and again being setting up for the next operation. So, again worker is busy in M2 now. So, after that it will start working. So, that is the running, and here for M1 it will finish at this time, and here again it starts working. So, this is the main idle time. Here both machines are busy and worker is in rest position. Okay. So, that is the idle time. So, you can see here idle time from case 1 and case 2. So, if I can say idle time of I1, here I2. So, I1 is greater than I2, idle time. Now, I am taking third one. One worker operates 3 machine. Here you can see M3 already working and M1, M2 is already working, and M1 is being set up by worker 1. Okay. Here worker is involved in a machine 1. After that, what will happen? It will start working, running to processing something. So, in that time that machine will get stopped, and here machine is waiting for being set up for another operation. So, here is this idle time is for machine, and here worker, because worker is not free in this time because he is involved in setting up M1. Okay. After that, what will happen, that worker will again go to the machine M2 and he will start some pre-processing, so that machining will start. Okay. And in that time, in some between in that time, what will happen, M3 operation of M3 will complete, and again it will start, he will wait for another operation, but because here worker is busy in M2, and after that again this will finish their work and he will go to the M3 for being set up for another operation. And you can see there, for each machine there will be a some idle time, but worker will always busy. So, this kind of arrangement is made in a industry, so that idle time can reduce, okay, or finally productivity is improved. Okay. Now, flow diagram, this is another way to represent your operation. Here this is the very simplest technique, and it is the plan view of work to a certain scale and link diagram indicating the path followed by the objective under study. Here path is made by flow diagram. It gives an overall view of an existing proposed process and is used for making improvement. Okay. It shows the path followed by the material, man and equipment. Here for example, here you can see that first one material is taken from store, that is for already in storage point, you can see the symbol, then it is transported to that workshop A. Here there will be some operation, after that again it will transport to works through the 2 route and it will reach the workstation 2. Here there will be again some operation on that machine, that product, again it will transport it to workstation 3, where again some operation will be there, then it will have a some temporarily delay, and after that here you can say that after some inspection will be also there, and after that it will transport it to the storage section again, and from that this product will go out to the market. Okay. So, this is the simplest way to how it will movement, it records movement of your material. Now, after that was the all the things was the method study. Till now we have studied the what are the how we will do analysis of method analysis, and we will how we will perform job design, so that for a work system. So, in this module now I am closing this module, and in the next module I will cover the next topic, that is called motion study. It means either you can say time measurement of for a work system design. Okay, thank you very much.